In this video, I'm going to talk about conditional logic and expressions. We're going to introduce a new data type. We've talked about the int data type, the string data type, the double data type. Now we are going to add the Boolean or bool data type. The bool data type can hold two values and only two values, the true value and the false value. Now true and false, they are keywords in C#, but they're not variables, they're not strings, they are Boolean values. So if we declared a bool data type in C#, we could store the value true in it. These Boolean data types are useful when using Boolean algebra and creating logical expressions. Alright, so we're going to learn how to create conditional expressions. We have to be able to create conditional expressions in order to start creating branches in our programs. But first we'll look at conditional operators. We'll look at conditional expressions. A conditional expression is when two values are combined with a conditional operator, like one of these operators listed above. Very similarly to algebraic expressions and algebraic operators, where an algebraic expression like 3 plus 2 takes two values and combines it with the algebraic operator, the plus symbol. Algebraic expressions produce numeric values, where conditional expressions produce Boolean values. So for example, here I have a conditional expression. I've combined two values with a conditional operator. This creates a conditional expression. And this expression reads 5 is less than 25. Now if this expression is true, it's going to produce a Boolean true value. So 5 is less than 25 produces the value true. Just like if this were 5 plus 25, the algebraic expression would produce the numeric value 30. Let's look at some of these conditional operators in more detail. First, we'll look at equality operators. There are two equality operators. The first is a pair of equal signs next to one another. This stands for is equal to. This conditional operator produces the value true if the values on either side of it are equivalent, are the same. Otherwise, it produces false. So the expression 4 is equal to 4 would produce the value true because the two values are the same. But the expression 4 is equal to 5 would produce the value false because the two values are not the same. The complement is the exclamation point equal to operator, which reads as is not equal to. This conditional operator produces true if the two values on either side are not the same. So for example, the expression 10 is not equal to 2 would produce the value true because the two values are not the same. Next, we'll look at some relational operators. We have four relational operators. Relational operators are testing the ordinal relationship between values. Ordinal meaning which value is greater than the other. So the four relational operators are the less than sign, which is less than, the greater than sign, which is greater than, the less than followed by an equal sign, which reads is less than or equal to, and finally the greater than and equal sign, which reads is greater than or equal to. And if you can't remember which, if you look at a chevron like this and you don't know, well, is that less than or greater than? I can't remember. Well, think of that symbol as an alligator mouth, where you have the bigger end is the open mouth. If the open mouth is trying to eat the larger value, then the expression produces true. Otherwise, it produces false. And finally, we're going to look at three logical operators. The logical operators work a little bit different than the conditional operators because the logical operators links multiple conditional expressions to create larger conditional expressions. For example, if I had the conditional expression age is greater than or equal to 21, and I had the expression cash is greater than 20, I could use a logical operator to link these together and create the expression age is greater than or equal to 21 and cash is greater than 20. I want to test this entire logical statement. So let's see how they work. The two ampersands together represent a logical and the and operator produces the value true if and only if both of the conditional expressions are true. So for example, if I wanted the expression age is greater than or equal to 21 and cash is greater than 20 to be true, then both the left and right expression would have to be true. If either was false, then the entire expression is false. The OR operator is defined by two pipes. The OR operator produces false if and only if both conditional expressions are false. In other words, if either expression is true, then the OR operator will produce a true expression. And finally, the single exclamation point represents the logical NOT operator. Now, the logical NOT operator works on a single conditional expression, and all it does is flip the logic. So for example, if a conditional expression was true, if you put a not operator in front of it, it would become false. For example, not true is false. Let's look at some examples here. So let's figure out which values would make the following expressions true. Well, here's our first expression. Age is greater than 21. Well, for this expression to be true, the value in age would have to be larger than the value 21. So if age was any value from 22 and up, this expression would be true. Otherwise, it would be false. Now, if I wanted to compare, if I had age 21 and I said 21 is greater than 21, well, 21 is not greater than, they are the same. If I wanted to test for greater than and equality, I would use the greater than or and equal to operator. Let's look at our next example. Name is not equal to the string Al. In this case, this expression will be true if for all values of name that are not the same as Al. So any name would produce the value true as long as it was at the name Al. Exactly Al. Capitalization counts here. Let's look at the next expression. Here we have not salary is less than 55,000. So before we work on this not operator, let's look at the inside. Well, the inside would be true. Well, let's look at we want to find out when the expression is true. So this expression is going to be true when the inside expression is false, because not false would produce true. So let's look at what values would produce a false in this salary less than 55,000. Well, the salary less than 55,000 would only be true if they were for lower salary values than 55,000. So if salary was the value 55,000 or higher, the inside expression would be false, and then not false would be true. So this expression would be true for all values salary is greater than or equal to 55,000. Logic can get confusing, or it can take a little while to work through. All right, next example here. Here I have a logical operator OR combining two expressions. The age is greater than or equal to 21, or cash is greater than 150. Now the OR operator will produce true if either side is true, or both are true. So any age value that is 21 or higher would produce a true for the entire expression, regardless of what cash value is. And here, any cash value that is 151 and higher would produce true, regardless of whatever age value was. So in this case, either of these expressions can be true for the entire expression to be true. Now what happens if I change that OR to an AND? In this case, both expressions must be true for the entire expression to be true. So for this expression to be true, age must be a value 21 or higher, and cash must be a value 151 or higher for this expression to be true. Once you have a grasp on how to build conditional expressions, we can start implementing decision blocks in our code.